Good morning.
Morning. Tim, you look so serious.
Well, this is serious business here, defining the future of cloud native telco.
Ah,
Wim, have TSC elections happened yet? Do you know?
no?
Oh, you're muted.
I think tomorrow I think in the TSC, I think so. They will probably announce. I don't know.
Okay.
What? You haven't been sending out bribes to the rest of the members?
On this is being recorded, so let's keep that kind of.
Sorry,
subterfuge.
that was a joke. That was a joke. Just to
I-
clarify, I apologize.
The TSC is not bribable anyway.
Yeah, I was joking.
Very serious, very serious. So John is back from vacation, but he's ill, unfortunately. So
Oh.
I will just step up to be a temporary chair, and we also still don't have a co-chair, so officially. So yeah, so we'll. But all I'm really going to do is coordinate the meeting today, and on the agenda, let me share my screen because I'll also be presenting, so that makes sense. So we have the agenda today got filled by 3 topics. I will be presenting for about 30 minutes, continuation of our discussion from last time, which was a continuation for discussion from before that. Alexei also has a presentation that you can already see the slides. And thank you very much, Alexei. He made his presentation speak to mine in a way that keeps the conversation coherent. I think we all like to see that. And Vish would like an update on planning activities for R1 from our chairs. As I mentioned, unfortunately, we are chairless still. We have John, but he's ill. I think Stephen is here too, and we might be able to say some things about Google's ideas so far, but we don't. I don't know exactly what the planning activities for R1 are entirely.
Maybe we can leave it next week then, when John comes back, or when the
yeah. I think that would be better. And if you were at the SIG #1 meeting, the ad hoc that was created because there were trouble, Kaushik mentioned that he very much wants to have SIG #1 ideas on R1 requirements. So in a way, we're also tied to those. But we're marching forward anyway. We don't need a real plan to start to finalize architecture, structure, list of components. I think the conversation has been moving forward.
So just to give context, the plan is, hey, how should I get involved? And how should I actually go back to management and say that, look, I'll be busy for the next 6 months working on this, right? In general, I'm sure others within the community also probably want to know, right?
You're absolutely correct. Yeah, I think all of us want to know exactly, okay, here are the components that we're working on. To an extent, we kind of know what they would be, right? That there's something to do with networking, something to do with CRDs for network functions. We kind of know what they are, but to an extent, SIG #1 will give us the priorities so we can decide which one is the most important one and create maybe stretch goals for R1. At the end of the day, everybody in the community will work on what they're passionate about working and where they want to volunteer. So if SIG #1 says that there's a big requirement for something, but people on SIG #2 think that something else is more important, I mean, they could absolutely work on that. We'll welcome any work rather than no work. I think that's how this works, right? At the end of the day, the communities decide what to focus on. But yeah, let me start with the presentation for today. So I gave a little blurb about it. I hope everybody can see my screen okay. Yeah. I always forget how to present here. Slideshow. So here's the context. So last week, We talked about how to extend CRDs. Wim gave a presentation about how Gateway API does it and said, well, we could do something similar. And I said, well, we need to complement this with the implementation. You know, how do we actually add implementations that would deal with that meta model? And I suggested that we could look at Go plugin, a library that is used by HashiCorp. But looking more closely at it, I realized, well, that's really not what we need. The Go plugin library is designed for, yes, running plugins at runtime. That could be separate executables entirely, but it's designed for in-process work. What we need is something that's really cloud native and designed to work with pods in the Kubernetes world, and something that would also match the meta model that we'll eventually use, right? We can still discuss how that would look. So over the long weekend, I created this library that I'm calling kplug. What does it do? The idea is to make both operators and CRDs easily extensible. So it's actually two functions in one. On the one hand, it does propose a meta model. So it's very similar to what Wim presented. And Alexi will talk today, I think, about another kind of meta model from the cluster API. So yeah, I'm proposing a meta model here, but it's not absolutely required that we follow the structure I propose here. I think it makes sense, but it's kind of a small thing, right? If we choose a different meta model, then we could, you know, modify the code to support it as well. But the real point here that whatever meta model we choose, however we extend some sort of basic agnostic custom resource, the operator does not have to understand the content of those. Internally, the library, the kplug library, uses the dynamic code path in the Go client API. Those who are deep into Go programming for Kubernetes might know what I'm talking about. But usually in the Go plugin, Go is a very strictly typed language. So you tend to work with types that you define strictly, right? So you know what the APIs are working on. So if you're using a custom resource, you have the schema, the structure for that CRD. So what do you do with extensions that you don't know about when you compiled the operator? And that's where we use the dynamic code path, which doesn't have to do that. So it's kind of like turns it into a dynamic language where you can read resources and you just kind of get the YAML-like manifest structure from it, but you don't actually understand the semantics of it. So the operator does not have to understand these extensions. And the reason it doesn't have to is number two, where the operator can delegate work to plugins. And that is where it kind of looks like Go plugin. These are implemented as gRPC servers. And again, the kplug SDK makes it very easy to set it up. I'll show you how incredibly easy it is. So the plugins could then read those extensions and know what to do with them, right? So all this makes this extensible, you can say, at runtime, not at compile time. You can create an operator that knows how to do basic things, and it can delegate work to plugins that can know how to do extended things that it was never designed originally to do. So I'm just going to show a demo, and then we're going to go back and talk about a few more slides about how I think this could work with Nephew. So I linked the kplug repository. I made it Apache licensed. And the README is pretty good, I think, if you want to go through it and understand how everything works. But I'll do it quickly right now. I hope this is big enough. So there is an example. And let's take a look at it. So the example comes with one operator and one plugin. And actually, you can follow this page and it'll work. I'm using, I created a little mini cube here, but you could probably use any Kubernetes distribution you have. And the example I'm showing is not a Nephew example. I wanted to just understand this kplug thing conceptually. So this is about a database table. An was just asking about it. The idea is, let's look at the resources. So here's the example resources. Here's one custom resource. I'm just calling it myOrg.org. Brilliant. The database table is designed to, I need a table from a database. This is the custom resource that I want somebody to reconcile this with reality and make sure that my database table exists. Here are the columns I want for the table. And I want to be able that if I modify any of these columns, if I add a column, remove a column, change the type of a column, the operator will know what to do. So, it would translate that column in the database. It will, if I delete this custom resource, I want that database table to be deleted. So yes, you understand how declarative orchestration works. I don't have to do that. So this part should be pretty clear. What is the addition is this, extensions. Now, these are just object references. And here I'm saying, yes, I have this custom resource that I designed very carefully, but then I have these extensions to the custom resource that are these optional additions, right? Let's look at them here too. So one optional addition is for a MariaDB extension to this. And here it is. And what it does, it specifies a storage engine for MariaDB. Now, this is implementation specific, right? If I'm talking about a general database table that's supposed to be agnostic to any database situation, I don't want to add that property here because that's specific to MariaDB. But not only that, I might not know about these properties in advance, right? Maybe in the future, somebody's going to add an extension for a new database that I didn't plan about, and it has its own properties. So these extensions allow for extending the custom resource with other custom, with other special properties for it, right? And all of these are simple pointers. This is a very standard Kubernetes API structure, right? There's libraries that handle this for you. So yeah, it's just the version kind. You can also specify a namespace. If you don't specify a namespace, it will just expect that resource to be in the same namespace as the base, which is right here.
A question, if I may.
Sure, please do. Yeah.
The extension is running where? Is it running within the pod of the main operator, or is it external?
No, it is not. And we'll talk about that. So there are two separate things here, right? The extension has nothing to do with the plugin per se, right? Right here, we're talking about design. I'm not even mentioning, what is actually going to actuate and reconcile this. So first, I'm just talking about the meta model, right? So yes, I can give extensions, but who's actually going to be able to handle those extensions, right? The operator doesn't know about these. It wasn't designed to know about these. It only knows, to reconcile this basic table, right? So let's look how we actually implement this. One thing about the important to note is that semantics are really domain specific, right? So in this case, the database table.
Yeah. John has been raising his hands for a while.
Oh,
I
sorry.
think he's on mute.
I'm not hearing any.
No, that's fine. I just wanted to let you know. I know since you're presenting, you'll not be able to see it.
Thank you. I do appreciate that.
Yes, thanks. I just wanted to make sure that he turned his video on. He wants to talk.
Here's what I recommend: that while I'm speaking and I can't see it, please just jump in and talk. It's okay to interrupt me. I have no problem with that.
Yeah. Okay. So can we go back to the definition, to this? Do you think that what is in the main part, the spec, and what is the extension belong to the same role or persona? Because basically what you are describing here as extension is not so much an extension of the intent, but how you realize the intent. So
you're right.
So should it really be part of the same resource and be considered an extension of a resource? That's something that we need to discuss.
Yeah, you're absolutely right. And when I get to the next slides that I have, I'll talk about how this can affect Nefio, and I think that's where we will discuss the roles. Right here, I'm just showing kind of a technical solution, right, and not really talking about how it could be used, and because that's exactly true, right? That it could be entirely different roles dealing with each aspect of it. And I was just getting to this right now when I said the semantics are domain specific. So the roles are domain specific too, right? If we're talking about a database table, you'll notice that I have here something I call preferred implementation, right? So whoever implemented this might say, I prefer to use MariaDB if it's there. If it's not there, and in this example, it's actually not here. So it will just go to the next extension, right? Or any other plugin, sorry, that's there. The plugin name does not necessarily have anything to do with an extension, right? For example, maybe I want a PostgreSQL implementation, but PostgreSQL actually doesn't have any special properties that it needs. There is not a one-to-one mapping between plugins and extensions, right? The extra implementation, actually, we might not need any custom resource extensions at all. Maybe the base custom resource has everything that we need, right? So these two things, right? In my first slide, I was careful to show that there are two functionalities here. They're not necessarily related. They really are separate and can be used separately. So yeah, just to be clear, there's design extension and implementation extension here. So I'm saying that I prefer one solution, but that might not be the case for every type that we were doing, right? There might be a certain type where all the plugins are necessary to work, right? Or there are multiple plugins that might be working of different kinds. And I'll get to the example more. Let me just finish with the demo, and then we can talk about what it all means.
I think one of the other reflection, I think, Tal, that you can have is like take the storage. You have a default storage class, right? If you basically want a PV and you don't specify anything, you get a default storage class. I think it's similar to that, right? Or and
exactly. So we can probably identify different kinds of semantics, right? There are semantics of you have a custom resource and it can only have one implementation, right? That's not always true for everything, right? There are things that there might be multiple implementations working at the same time. So there could be a one-to-one mapping, a one-to-many mapping, or even a many-to-one. I can think of an example of that. But anyway, I'll move along a little bit. So in the example, so let me set up, let's just run it first. So I will, here. I will do a queue control apply of the, let's install the operator first. Oops. All right, so the operator should, getting a deployment. There we go, we're green. So we have the operator running, and I will notice it has a service too called database table operator, and the service is actually an important part here. We'll get to it. If we look at the logs, here we go. It's set up. It started a gRPC server too. We'll talk about what's going on with that. And it's not doing anything right now. Now I will also install the MariaDB CRD that we saw. It only has a CRD, and then the Postgres plugin as well. And I'll just show you very quickly what I actually applied. We're probably going to get, here it is, the Postgres plugin. So you can see exactly the files I applied. So the operator here defines that CRD that we saw, which is the base set here. Nothing very interesting here. It does all the usual RBAC stuff, role binding. Here's the deployment of the pods itself. And here's the service that we created as well. And the service is to give us access to a gRPC port over a known name. So that's important. For the MariaDB plugin, we're creating that custom resource extension that you saw, but actually there's no plugin itself. That's done on purpose to show that it will just go to the next plugin. So the Postgres actually does have a plugin running that we just saw, and it also has a service for that. Let's look first at the plugin code. It's written in Python. This is it. This is the entire thing. It uses the kplug SDK here. Very straightforward code. So it starts a server, the kplug server, and it also starts a heartbeat, which will register this plugin. The heartbeat uses those known names that we set for the Kubernetes services. So here I'm starting a heartbeat to the database table operator. And in the heartbeat, I'm sending this plugin information that tells the operator how to delegate to me. So I'm giving my service name, right? So this is the service name. If I go to services, This is this one. So it will know how to reach me. And I'm giving some registration information here. I'm saying, which version I am and kind of what I'm expected to implement, right? Because a single operator might have numerous plugins of different kinds. So I'm not really doing anything with this information now, but it's just for registration to make sure that I'm delegating to the right component. So this is just the usual setup, very small. The Kplug SDK does everything for me. And here I just apply the implementation, which is I'm getting the base custom resource. And here I'm extracting the columns that you saw. And then under extensions, what I'm doing is I'm going over all the extensions and looking for an extension that I can support. So I'm looking for that database table PostgreSQL extension here. And I know I support it. So I'm able to, from the extension, extract the partitioning information for my PostgreSQL table. Right. And once I have that, here's, I didn't do it actually, but here will be the logic of creating that table. Probably a SQL command to Postgres using, I would be importing some Postgres API connection here. And then in the return, I can do something interesting. So I return 2 values. One tells me what the status update for the base custom resources. And then per extension, right, every extension has an ID that's created internally. Per that extension, I can tell it add extra status for it. And I'll show you exactly how this works because I am now going to apply that example stuff that I showed you initially. So
Charles, sorry, just for a fraction of a second, I just lost my concentration. So the code that you showed, was it for the base one or the Python code just you showed, was it for the base one or for the extension?
Any implementation gets everything. So it'll get the base with all the extensions. I mean, all of that is part of what the custom resource is. Every single plugin will be able to know what to do with what it knows what to do, right? It might recognize some extensions and not others. It's kind of up to it. It has a view of the entire custom resource, which conceptually is divided. It's one thing. It's one logical thing, but it has extensions. Maybe it knows how to recognize some extensions or maybe not. It's kind of up to it. But it can do anything it wants, right? It's not limited.
I think
at least.
Total, what Balan was asking, I think, was the code that you showed. My understanding is it's the extension code. It's the thing.
Yes, this is the code for the PostgreSQL extension. This is not the operator itself. And I wanted to show how easy it is to really implement. This is written in Python, very, very little code. There is nothing to do with Kubernetes here, right? This is a gRPC server. Whoever is writing this, right, writing this sort of plugin doesn't have to know a single thing about Kubernetes, right? They only have to understand their domain and what they're implementing here. Now, they could use Kubernetes, right? If you want to create, let's say, a cloud native plugin that is able to interact with Kubernetes in other ways, I mean, you can import the Kubernetes API and do Kubernetes calls as well. It's kind of up to you, but at least you don't have to understand the operator and its logic internally. You only have to supply this implementation class, really. That's all you need to do. Right, so the SDK does everything for you, and it will also handle packaging. So it would automatically create this deployment and everything that you need to do. So that's the easy part. So
just sorry, one question. What will this return? What is the outcome of this extension for the byte?
That's exactly what I want to show here. So here's the extension running. So this is the log that it does. So you see it keeps sending the heartbeat. And it gets accepted true from the controller. And then we can see the controller is actually sending its command. So it's telling it to create the database. And I'm just showing. So this is exactly the implementation. I'm doing this logging debug. I'm printing which columns I got and what partition by I got. The partition by is a PostgreSQL specific property from the extension, from this extension. So that is only can be handled by, MariaDB doesn't know what that is and won't know what to do with it, but we know what it is. So yeah, so this is, it's getting what it needed. Let's look at the logs for the operator, what's happening on the operator side. And we'll look a little bit at the code of that too. So
By the
the
way,
operator,
Vish, if you want to say something, or I don't know, you have your hand raised, maybe I think you should.
please just jump in and
Yeah. So I think this is more a question for, thanks, Tal, for this information. I'm trying to see some analogy to what, we had in OpenStack for advanced networking services. So, and I see Stephen Wong here. It's more of a question for Stephen to see if he also felt this was similar to something that I know he also was mentioning about operators back then when we went to the developer summit. And I was actually trying to ask him back then, are you thinking about something very similar to the plugins that we used to have in Neutron? This is the analogy you see, Steve? Because that's what I think I'm feeling familiar with. It seems like that worked. Do you see a similar analogy, Stephen Wong?
Well, the back in OpenStack days, obviously the first thing we do on Neutron or some other things are all using plugin architectures to ensure that individual implementations would be using the same APIs and be able to actuate the APIs from OpenStack. This actually is communicating, so it does a little more than basically just doing Fandel on different vendors or different drivers, different plugins. Case.
Of course, this is mainly for Kubernetes.
See, if I may, I think, this is a way to use gRPC-based services. If you look to the way, I think there's multiple ways to achieve this from an implementation point of view. Here you have really use gRPC communication service to communicate. There is other approach. If you look to what I think, in my view, if you take what Kept is doing, or in so there is other implementations, they use function as a service, right? So you basically can inject the function dynamically, either through you just spin up another container, can be Knative or something, who executes something, give you a result.
Right, that's a one-shot kind of.
So you have. And you can basically, depending on your intent, invoke those functions. And then you have other, if you take crossplane, they have more of a composition type of thing where it's predefined and stuff like that. So I think there's multiple ways to achieve this thing.
That's very true, right? Because, for example, if you could do something like that Go plugin that I suggested, and really, to run a plugin, you can also just run an executable, right? Yeah. You don't have to do something like this. But I specifically was looking to create something cloud native where you could have a running service, right? A plugin could be really big thing, right? It could be a complete VNFM running there, right? That works as a plugin for a main operator, right? So I showed very simple code, but obviously some implementations could be very big. Right, so you might have a service running all the time that's very stateful. You could have a plugin that's very stateless, right, and it could just be a one-shot thing. So,
Because if you look to the IPAM that I did during the POC, it's actually two parts. So there is the injector code that actually runs as a controller, and today the IPAM pod has both things in the same pod package, but internally there's a gRPC service. So in other words, the idea was always to decouple, to be able to decouple them so that you run the injector on somewhere, wherever you want, and then the IPAM server somewhere else, and then you can basically detect it. But for the POC, we basically package it all in one.
Right. Well,
so that's actually a good question for you, Wim. If you were to change an IPAM, create an IPAM plugin that would be able to get into your IPAM services, would you consider that as a third-party person? Would it be easier to integrate into the system, or is the other way something that is more elegant or better or more, or probably not easier? I wouldn't think, but yeah.
For me, the IPAM. So if you look to the IPAM, here we are talking about a specific intent, right? That has to be complemented with things or extensions that are potentially required based on some logic that you have. Either the user specifies it, or it is determined by some runtime information, and so on and so forth, right? So for me, the IPAM was a bit different, because in my view, you have like a gazillion consumers now. So that's for me the essentially a criteria to determine what is the best architecture. So if you really say, so here, let's say we have a DB intent, or I don't know whether I'm saying right, Tal, and you want extensions to fulfill that, right? So that's kind of the thing here. So there is more of a, I would say, a one-to-one relationship. If you say that these extensions would be used by intent 1, intent 2, intent 3, intent 4, right? And they are all, and it's becoming like a generic service that is augmenting various things. So for me, IPAM is an example of that, because I think you want in the system as probably a central IPAM that basically gives IP for the whole Nepio deployment, or at least that was my view. And then you have multiple, so the injector was distributed. So you probably have, so you could have one for, let's say, networking, another plugin that is being used for the network functions, another plugin for cluster. So you had, so basically multiple clients that were consuming the same service. So I think these are all parameters that probably define what is the right architecture to support this. Yeah, I think Jean-Marie as a sentence.
Yeah, I have two comments. First, if we want to be robust in terms of architecture, we need to be agnostic to how the intents are implemented underneath.
Yeah.
So that's something that we need to be very careful that we are not locking ourselves to a single realization. The comment, more importantly, that I would like to make is that we need to make a clear distinction. I'm hearing a lot of confusion at the moment between I'm extending an intent versus I am expressing how I realize an intent. And what I have seen so far is absolutely not extension of intents. That's implementations, that's realization of an intent. And it's very important because that's not the same persona or the same actor at all. The intent is from the consumer perspective. Okay, so if you take the database example, the intent, the table and the columns is from the application developer perspective.
I agree.
I agree, yeah.
The other thing is not at all an extension of what is the definition of the table. It's from the database SRE or the DBA or whoever perspective that, okay, what database will I use to satisfy that table? And so
this is, I'm sorry to interrupt.
In my opinion, it should not even be in the same CR, because a CR should be sourced by a single actor.
I do want to, I'm sorry to interrupt, but I think I might have some answers or responses in the coming slides. And Alexei has another conversation that I want to get to as well today that kind of continues this. So I absolutely agree with what you said, right? That the semantics, and I try to emphasize this, are different for everything. So I want to show some more examples from Nepio, and I think they'll show different semantics. Maybe that'll clarify things. So I just want to finish and show that this works. And then I'll discuss how it works. It'll just take me 1 minute to show. So if I look at the actual operator logs, you'll see it keeps receiving those heartbeats from the plugin. Right. Again, the plugin is not equal to the extensions. There is not a one-to-one mapping between them. There might be extensions, there might not be extensions. At the end of the day, these are different implementations or implementing different aspects of the same custom resource, right? We could potentially have a custom resource with 3 kinds of plugins, each one handling a different part of that functionality. I'll get to that. So yeah, here we're getting, it's calling the plugin. So it's processing the work item. We have the users table. It's calling the plugin for it. And it's receiving the responses from the plugin. So those are exactly those things that we return from the function. So on the one hand, it wants me to update the status for the main CR. Sorry, for the extension CR here, and then for the main CR. So if I actually look at those CRs, so here I can see the database table CR. We have one object. And you'll see in the status, it told me to update it to PostgreSQL for the implementation. So now I know what implements this CR. And then for the extension, it specifies partition true. I asked it to be partitioned by, and it returned that, right? So in the code here, this is exactly what I returned here. So it did the right thing. So I won't show you the operator code. We don't have time, but I do want to go through a few more slides where I explain, okay, what does any of this mean for Nephio? So I'm going to give two examples of where I think
there is a hand raised by Alok. Maybe if you want, you can speak up, Alok. Right?
Please speak up. Yeah, feel free to interrupt.
Yeah, thanks, Wim. Just a quick comment on what Jan-Marie was also mentioning and touching down on. I mean, the high-level intent and then the actual realization through that implementer. It differs in the sense that whether we are realizing a database that we have seen in this example or some secondary networking, right, through the demos that we have seen in the past, either through KNAP or ENO. And so at what level of intent that we have to provide to this K plug? So it's explanatory as well as generates the right CRs for the next operator to implement the actual or to realize the actual code. So I think that's what I'm.
Yeah, Kplug is a mechanism, right? So it doesn't have any opinion about, your semantics. We're going to get to that, and LXC is going to get to that too. So I want to move along a little bit, and I think some of these comments will be answered maybe by the presentation. And we can definitely continue to discuss on Slack and next week, of course.
Yeah, let's finish the presentation.
Yes,
let's have a QA for 5 minutes and then move to LXC maybe. After you finish your presentation.
Okay. So here's an example from one aspect of what Nephio would do, right? Having a shared base for defining a UPF. And so this is purposely similar to what we saw with database table right now, that we would have only one implementation, right? If you're defining UPF, there cannot be two. You're deploying it, and it's either one or the other. So we can have an extension for free 5GC, or maybe for using open air interface instead, and they might have their own properties. So very similar to the database table example that I just showed. The plugins, right, would be different as well. So a free 5GC plugin would rely on that UPF extension data, right, for the extra configuration that it needs. Its job could be to generate the actual deployments for free 5GC and the config maps. So this would be a cloud native plugin that knows how to do some Kubernetes stuff. Open air interface might be different. It could rely on the same UPF extension that it has, right? But then it might need to create deployments with different images, right? Because I'm choosing the acceleration here. So every plugin could have its own semantics, but of course they have to share the same intent, right? The basic idea of what they're participating in. As another example, I wanted to show something quite different where you have the main intent. So here is a workload cluster node group, right? I'm saying how many nodes I want, which kernel I want, which CNI I want installed in them. We talked a little bit about how this could look. I'm just giving a demo here, right? I'm not intending this to be real. And then I say I'm giving extended things for different, which extensions of different kinds, right? This first extension would be used by a cloud platform extension, right? So we might have different vendors. This is my cloud vendor. And the my cloud vendor has extra properties that it has that might not be shared by others, special features that they have. But then the other plugin here, the other extension refers to a plugin that's very different. This is from an equipment vendor, right? So here we're starting to see different roles, right, being involved in each one. The equipment vendor can say for this node group, I need to configure the SmartNICs on those nodes, right, and give some SmartNIC configuration stuff. So these are two entirely different domains, right? Entirely different kinds of extensions for entirely different kinds of plugins. And that's okay too, right? So we can have conceptually different roles involved in the same intent, right? So this is the example I wanted to show, that we don't, the semantics are up to us, right? We can use this mechanism to define different things. We don't have to model it this way, right? If we want a very, very clean separation of roles, we can say that there will be different CRs for the basic, right? There might be one CR defining the workload cluster, and an entirely separate CR defining equipment. That is absolutely up to us, right, as a community to decide our CRDs and the relation between them. And that's why the discussion about roles is so critical. Now, conceptually, they can all work together. And remember, an operator can also work with multiple CRs. That's actually often the case. You do not have to have an operator that only supports one CRD. The operator can actually support a whole tree of CRDs that are related to each other that create a topology, right? So
we have more questions, I think, but we have to do it.
Yeah, I know. I'm basically done.
Yeah, let's ask the questions after the presentation. Yeah,
maybe we should do it.
I'm done. I'm going to skip the last slide. I think you can fill it up.
They're like 3 hand raised.
Yes.
I guess
Okay, yeah.
yeah.
I think I was keeping track. Ravi was first, then myself, and then Dimitrius. Yeah.
Okay, shall we ask questions or we wait till the next presentation?
No, I think we should ask the question for this.
Oh, okay. Yeah. Okay. I was just trying to understand, mostly from a telco domain perspective, where everything needs to be. I mean, generally, though we say multi-vendor, a lot of it is tested in some vertically integrated manner. All this interface and all, but is this? I mean, there's no concept of kind of leaving something in runtime or for a choice. So I'm just thinking, is this kind of applicable to telco kind of workloads? Or if you basically say, I want to do UPF, then pretty much everything is understood. And when you understand what the cluster requirements, you ensure that cluster has everything, all the resources, and then you deploy the UPF and so on. So I'm just trying to understand where this kind of plays in that space.
So yeah, I think I wasn't clear about what the problem this is even trying to solve. Here's the thing, you can, as an equipment vendor, you can write your own operators for everything you have, right? And make sure that they're managed properly. That's what we've been doing until now. Nefio is trying to create a unified platform, right? A common set of operators that we can all use and not reinvent the wheel every time we're deploying functions, and also have the semantics and the modeling and the design be coherent, right? So, if I'm using equipment from vendor A versus equipment from vendor B, we hope that they're all doing something cloud native when they're deploying on Kubernetes, but they'll have very different configurations, very different CRDs, different ways of installing the operators, different requirements. Are some things running in the management cluster or in the workload cluster, right? But Nefio is trying to define a complete flow. It takes into account that there is something called a management cluster, right? And finding common ways for network functions to specify requirements they have from the infrastructure, right? So all these things we're trying to align. So we want to make sure, in my vision, at least for how Nefio would work, that we have a common set of operators, but then we need a way to, if they're decoupled from the implementations, we need a way to integrate those two, right? So I think that's part of what we're still trying to deal with.
Yeah. No, and I'm just trying to understand is that exactly. I mean, of course, there's open APIs that's basically coming from some OS-based system, which the operators will try to work on or kind of process and come with more granular requirements for the cluster. But what I mean, what I'm trying to say, there's no sense of non-determinism, right? Everything is quite deterministic. You're expected to work in a certain way. There's nothing left to choose that, okay, this is better than that. I mean, I don't think telco operators have that kind of mindset. Probably the enterprise world is different. I'm just thinking from that perspective.
But I think
that's my 2 cents.
If I may give a bit my perspective here. So I think what we are discussing here is more. So normally in Nefio, I think our focus should be on the high level intent that basically would drive this at the end of the day. For example, what I think some of these mechanisms would serve us to do is, for example, you have 2 vendors to do UPF, right? And you have a high level intent, I need the UPF. And then you have some logic that sits underneath to figure out which vendor to pick for a specific thing. So what we are trying to do is to ensure that the high level intent can be in such a way that you can then do like selection or definition on how you consume those. But potentially vendor A has completely different parameters than vendor B and how that would work somehow. So that's kind of, I think, the space that we are discussing this in, but this is more of the implementation level rather than the high level intent that we potentially have to focus on first before going here.
Okay. No, I'd like to see that case. Exactly. If you have two UPFs, does operator think in that way? I mean, for a given deployment, I would say based on his throughput requirements, speed usage, he knows, okay, this is a UPF I want. But yeah, I mean, just an open question. I was just trying to connect it to the telco world. Yeah. Others can. Thanks.
Just a small point. I think I overemphasize the idea that this can be plugged in runtime. We don't care about that, right? You usually have a management cluster that's extremely well defined, right? So you know exactly which plugins you're installing and everything, right? So this is not some sort of free-for-all system where where you can do anything you want. And remember, you have to, when you're actually creating your custom resources, you have to know if you're adding certain extensions. There's no some sort of runtime magic. You're designing your network function knowing which implementations you might be using, right? That doesn't change. Right, at the end of the day, we're not changing how people design blueprints and how they test and how they create network function deployments, nor network service deployments, right? All this does is allow for a decoupling in terms of Nepio and the implementation. Anyway, sorry, I know there's a lot more people here.
Yeah.
How do we do it, Alexis? Because
I have a feeling that Alexi's discussion will actually might answer some things, but I already see that, you know, I think generally we have to understand that in our SIG, presentations take far longer due to conversations. So Alexei, what do you say about maybe moving your presentation to next week?
I would suggest that, because
I'll move it to next week. I just wanted to put that slide in front of everybody because I think it can help with the discussion we're going to have now. But let's move what I have to present for next week. What basically, in a nutshell, what I want to present is start defining requirements for us that we need to implement. So, you know, this group is meant to deliver code, and I want to make sure we start thinking about these deliverables. Maybe we won't start with the perfect architecture. It will evolve. That being said, now back to all the hand raise. Sorry about that.
Thank you. Okay,
I think Niam was next, actually. Oh, Balaji is next.
Well, yeah. Thanks, Alexis, and thanks, Stephen. Yeah, Alexis, the reason I want to postpone is I think this the topic that you're presenting, Tal, and the topic that Alexis is going to present. I think it deserves the whole session by itself, to justice to both presenters and the audience. So that's I think thanks, Alexis, for moving the session to the next one. So Tal, on this one, I have a few observations. One is let's say so basically, if I understand correctly, it's a delegator pattern that you're trying to implement, right? So base has certain things, and the base operator will delegate to the extensions based on the definitions of the CR. Is it the right understanding?
Yes.
Okay, if that's the case, let's say we have a base operator defined in Nepio for, say, a UPF, and there are many UPFs, either open source or the vendor specific. So let's say vendor specific UPF, let's say Samsung, I'm just taking an example, or Nokia, whatever. Then we want to delegate to that one. So in order to delegate to the vendor specific one, the base operator needs to know about that particular extension. So let's say the base operator has not defined that.
No, it does not. So I'll stop you there. That my very first slide said that the operator doesn't have to know anything about those extensions, right? There is an API by which it calls the plugins.
So how does it know the gRPC endpoint?
Well, I thought that was the first thing that I showed, that it sends a heartbeat and it registers itself. So it knows all the plugins.
Got it. It's self-registering. Yeah. Okay. Basically, it's a server registering with the client. Okay.
Yeah.
Okay. So which one of so basically, thanks for setting my understanding correct there. So the base operator code will not change at all, irrespective of how many extensions we have. Correct. That's a good point.
Right. And it's up to us to decide, you can have an operator that does almost nothing, and all it does is really delegate all the heavy lifting to plugins. Or we can decide that there's a lot of commonality in the basic stuff, and that the operator does more work. That kind of division of labor is really up to our architecture, right?
Okay. So the second thing is there could be multiple implementation at the same time, right? You showed an example of UPF. You said one or the other. I just wanted to make sure that that was just an example, but that was not the mandate out of this architecture.
Yeah, there's no mandate at all. At least Kplug is just a mechanism. It doesn't have a strong opinion about semantics. Of course, the discussion of the semantics of decoupling is very important for us. For example, what you might have a one-to-many connection between. You might have multiple plugins working on the same custom resource, each of them having a different functionality, right? Imagine you have infrastructure with 3 different kinds of smart NICs. Each one of them comes from a different vendor with a different plugin. You need all of them running, not just one. So it's not always about picking one implementation. You might have multiple implementations needed, right? So those kinds of semantics really have to do with what you're modeling, right? At the end of the day, we have to decide how it works, right? Yeah, and again, it doesn't have to be a single custom resource. We can create a whole topology of custom resources as well, and each one of them can be extended.
Yes, because especially in the UPF scenario, there'll be multiple types. That's why I asked. So basically, that's not a. Just wanted to make sure that that's my understanding is correct there. The third point I wanted to raise is I know it's an operator. It's not a CNF itself. So the latency may not be an issue, but that is something to consider since we are communicating over gRPC where the parts could be running on a different nodes on the cluster.
Yeah.
So any latency considerations at all from the architecture perspective? I do not think there may be anything because we are not designing the CNF itself as a part of this architecture.
Exactly.
But that's something to consider.
All of this is orchestration, right? So all of this is only done for orchestration. There's no actually data or anything like that. This is about reconciling intent, which is already very slow on Kubernetes, right? You create a pod, it takes a few minutes, maybe sometimes until the pod starts up. So yeah, this is all about orchestration. Just dealing with etcd, I think, is orders of magnitude slower than any gRPC call. In my opinion, this would not be an issue for us, but yeah, when you start having extremely big chains of operators, which we've seen happen in some deployments, yeah, there's obviously a delay between when you first create the intent and then another operator creates another intent, another intent, another intent. Maybe for some use cases, that might be too fast, but generally Kubernetes is extremely non-deterministic, right? In the way its API works, because it's all based on polling. If you need a deterministic orchestration platform, Kubernetes is probably not it, just generally speaking.
No, yes, that is not what I meant to say. I totally understand that sentiment. I just wanted to re-emphasize the fact that latency, generally in an architecture, plugin architecture like this, latency is an issue. But what I was trying to convey my point is here, it may not be an issue for us because we are not designing the CNF itself out of this because we are not in the data path. So I don't think latency will be an issue with this architecture for us. So I think those were three questions that I had. Thanks, Tal. A great presentation.
Thank you. Very kind of you to say. We have more hands up.
Yeah. It seems like I was wrong. So the hand seems to be going from right to left. So I think Wadey is the first one.
Oh, okay. We're sorry about this confusion.
I know. Yeah. Sorry.
I'm not the official chair, so I don't have to worry about my responsibilities for coordinating.
Yeah. Thanks for the presentation. It's clear. So for me, I like the idea. So I found it good and fits. I have some of my questions are already answered. And I have only one concern here. So basically, we have two options. Let's say that we may have one operator that does nothing, that delegates everything to the extensions. Or we have one operator where we have the baseline there with the common functionalities. And this is where I see the most benefit. in order to monetize what Nephew would like to do in order to standardize these things. For example, I will take the example of the replica set. I see it rather within the operator than the extensions, because this is something that we wanted to have common to all implementation layers. We know in advance that we'll have multi-vendor implementation. We'll have, we are in the context with multi-vendor technologies. As soon as we are standardizing more things and putting in the operator more common, let's say, commonality, will be the best for us. So at least this is my point of view. I don't know, what do you think?
I think that's a good point. I think a lot of the feedback and comments I'm getting are, if I could relate them to each other, a lot of people are saying, well, my meta model doesn't seem to cover a lot of use cases. I think I suggested a meta model that I thought was very generic, right? The idea of extensions, I think people are understanding it necessarily as, it takes some base intent and add some other stuff for it. That was one example I gave. But there are a lot of ways you can use extensions, right? They could be kind of, it doesn't have to be a top-down or a left-right. Extensions are just pointers, right? So they could, you could create, you can create your actual model, right? It's a meta model. The actual model can have its own semantics. So I really think that Alexis' this presentation, if you go over the slides, he actually delves into it in depth. I'm sorry we couldn't get to it today, but I have a feeling that we're going to take this to the next level in the next meeting. And all of these points I think are really good ones. I actually agree with all of them. And my point is that, I'm not suggesting the actual models. I was just trying to talk about the meta models. The actual models, I think there's a lot of interesting stuff we can say about how we're going to compose it. And different aspects of Nephio have different semantics, right? Cluster and infrastructure versus UPF, right? This is kind of the big divide in Nephio, right? We have some CRDs that have to do with network functions and some CRDs that have to do with the platform, right? And we're constantly balancing or mixing up our conversation between the two. And semantically, they're very different kinds of domains. But anyway, yes, thank you. I actually 100% agree with your comment. Next, please.
I think
Next
I
one,
am.
Demetrius, right? Or...
Yeah. So thank you, Tal. That was really interesting framework that you have created there. And I just have two questions. The first one is that so you have the main operator and you have the plugins, right? And everybody understands the same kind resource. Is that right? So so from what I understand, the main operator does not actually do anything. That the only thing that it does is it just takes the common parameters that you have, and then it takes also the parameters from the extension and creates a huge custom resource that actually the plugin reacts on it. Is that right?
As I said before, the balance is up to us. I mean, you can have a very lightweight operator that delegates all of the heavy lifting to plugins. So the plugins can have all the meat, right? All the real functionality, or there might be a lot of common functionality that the operator does, so it really depends, right? A lot, if you go to the operator hub and download operators, so many operators are actually very lightweight things that all they do is kind of translate intent from one realm to another realm, right? So there are a lot of very lightweight operators out there, but there's a whole different class of operators that do a lot of work, right? Many of these have to do like managing a MongoDB cluster, right? That's a very common use case for operators, is managing stateful life cycles. So they might be doing a lot. It's kind of up to us. We might have a collection of 10 different operators in FEO of different kinds. Some might be very lightweight. Some might be very heavyweight, doing a lot of things and delegating only small things to plugins, if at all. So it depends.
Yeah, and okay, and the other question is, I mean, you said that this is maybe one-to-one mapping with the gateway API that Wim presented in the last meeting. I mean, in the gateway API, we have like two main custom resources. Let's say the gateway class and the gateway custom resource, right? But here we have, in your presentation, we have just one. so why we doesn't follow the same paradigm and have like a UPF class where you define all your implementations or that you have, and then you have an actual extra custom resource that you react on it when you need to create something really through
Yeah,
your
sure. Why
plugin
not?
there.
I mean, it's up to us. I try to give a hello world example that is as simple as I
Okay.
can.
No, just for discussion. I'm just saying that.
Yeah.
Well,
Dimitris, I think-
and I'll bring that as well next week. But Cluster API is doing something similar, but doesn't have 3 kind of CRDs. Just have 2, as presented in today's presentation. So it's a matter of us defining the boundaries.
And also, I think I presented Gateway API, which does that indirection. But I think the key is the reference to something outside of the main CR is through group version kind namespace name, right? So that's the KRM model that Kubernetes uses. So basically, by specifying a KRM object, which probably the main operator has no clue about, right? It's basically an index for something else. So that's how you have to look at it, right? And whether you use it with a class in between or you do it straight is, I think, depending on the use case and the roles and how the whole thing designs. That's how we have to then figure out what's the best way to consume it. But I think the main mechanism is group first and kind namespace name as the key to do so.
Yeah, I mean, if we use that class paradigm that we have in Gateway API, then we can have a role-based solution also in FPO in easier, and that is easier, I believe. But yes, okay.
But I think
I think that's an implementation thing, I guess. If that's if we decide we could do that, or we could do it this way too. I think.
Because for Cluster API, I think there's not, in Cluster API, there is not that intermediary role. So as such, I think they basically said, why do another object if we only need 2 roles? So they basically, I think Alexis will probably make it more clear, but I think that's one of the reasons why they only have they have a direct mapping versus the class-based indirection.
Yeah, we'll see. I think it depends on our use cases.
I think we are just over, but I think Liam has been raising his hands. Can we? I think we can.
I know Liam has been raising his hand, but I at least have to go. I know other people have other meetings.
So can we give us 1 minute to Liam, Tom? Is that okay?
Anybody?
Yeah, 1 minute is all I need. Yeah, I just wanted to just say thanks, Tal, for the presentation. I think we need something like this, even if the purist in me is a little worried about backdoors and things. But I was very interested in another comment though you made. I just wanted to, maybe we can put it on as for a future meeting. Is that Nepio is about operators and processes and a framework for working towards operators. So does that give some flexibility then as regards the tool chains for getting at those operators? Do you think?
Sorry, could you repeat exactly the question?
Yeah, so I guess what I'm asking is, you were explaining what Nepio was about there a few minutes ago, and I think you actually captured it rather well, even though maybe you were in full flight at the time. It was Nepio is about being able to coordinate or orchestrate operators. Was that did I miss the point? Pick up on it wrong?
Yeah, I don't think I'm changing the description of what Nepio is supposed to do. It's more about the devil being in the details, right? And at the end of the day, the community defines the scope, but we haven't really, we have the TSC general plan. SIG number 1 is creating requirements. It goes back to what. We don't have a list of components yet that we're all working on, right? This is exactly what Vish was asking about. Right?
Yeah, I guess we need to get to that soon. Okay, look at that's all I really wanted to say.
Well, thank you. I really apologize to people who have their hands up, but we have to respect time. I'm looking forward to next week's conversation. We'll continue with this and Alexi's presentation. Thank you, everybody, for your patience with me. And I'll see you next week.
And we can continue on Slack, right, if needed?
Absolutely. Please continue on Slack. Yes.
Thank you.
Thank you.
Thank you all.
Thank you all.
Thank you.
Thank you.